everyone! Today we are going to talk about forces on springs. I know it's an easy concept, but sometimes I feel like when doing an exercise like how was this or anything. So I will try to explain it in such a way that it can be more easy to understand. So let's go! So we will take a system of reference like this. This is the positive x-axis and this is the positive y-axis. So here we have our spring. Okay, so as we know, the force in spring is equal to K, that is the constant of the spring, times the deformment of it, that is delta. So delta, it's equal to the actual length of the spring minus L0, that is the length of the springs with any forces acting on it. So, for example, here, this spring measures L. So L0 equals L. So this is, we will take its L prime. So L minus L prime minus L prime minus L, if it's positive, the force on the spring will be like this. If the force is positive, it will be in this way. So the spring will tend to compress, to return to its equilibrium position. So, for example, if we have a rod, and here we have a spring attached to it, because of the Newton's third law that action equals minus reaction, if the springs exerts a force in this way, in the rod, the force will be in the opposite direction, so it would be like this. Okay, now we have here another spring. If in this case L prime is smaller than L0, that means that the spring is compressed. So the force on the spring is like this, because now the spring is smaller. Let's say this was the natural length of the spring. When the spring is stretched, it will be something like this, and if the spring is compressed, it will be something like this. So in this case, if we have here a rod and we have a spring attached to it, if this spring is compressed, because of the action equals minus reaction, that's the Newton's third law, on the rod, we'll have a force like this. So the springs will tend to pull the rod away. Okay.
Yeah.
So this was for the case of any spring. Now we are going to analyze what happens with an ideal spring. An ideal spring, it's a spring that when we are not applying any tension of any type of force on it, the L0 equals 0. So that means that the force of the springs will always be Ka, that's the constant of the springs, times the length that it's stressed. So that means that when we are not applying any force on it, the spring would be a point. So on these springs, they only both want to return to the equilibrium position. So this quantity will be positive always. So if, for example, we have here again a rod, it will take to So if this is our spring, the force is in this way. So on the rod, the force is in that way, that's such a way that it returns to its equilibrium position. So if we sum up everything, a spring always tends to return to its equilibrium position. For all the cases, if it's compressed, it will tend to expand and push any object that's attached on it. If it's stressed, it tends to compress, so it tends to pull any object. And if our spring is an ideal spring, it always tends to compress, because the spring only can be stretched. So that's all. I am Manesia. Thank you for watching. See you in the next video. Bye!